Good morning everyone, we are Group 3 and we'll be presenting on how physics improves energy resilience in Singapore. The relevant physics concept applies electricity and efficiency. Singapore is heavily reliant on natural gas. About 95% of Singapore's electricity is generated using natural gas. As a result, Singapore is vulnerable to fluctuations of energy cost in the global market, which in turn affects Singaporeans' energy resilience. As such, Singapore is switching to clean renewable energy, such as solar power, allowing Singapore to be more self-sufficient and less vulnerable to fluctuations of natural gas prices in the market, thus improving Singapore's energy resilience. So, what's the physics behind this that makes it possible? When sunlight hits the semiconductor in the solar PV cell, the energy from the light in the form of photons is absorbed, knocking loose a number of electrons which then drift freely in the cell. The solar cell is specifically designed with positively and negatively charged semiconductors stitched together to create an electric field. This electric field forces the drifting electrons to flow in a certain direction towards the conductive metal plates that line the cell, resulting in a current.
Solar panels are effective in improving our energy resilience as maintenance costs are relatively low compared to other clean energy options. Rapid developments in photovoltaic cells also reduces the cost of investing in solar panels, thus allowing a smoother transition to clean energy. However, one drawback of solar energy is that it does not work at night, so a battery is required to store the electricity during the day for consumption at night. Solar energy is also especially applicable in Singapore, as there's a smaller risk of extreme weather events, which can damage solar panel installation. And Singapore is also near the equator, so solar panels will also receive more solar radiation. To further improve the effectiveness of solar panels, we conducted an experiment to find out what angle solar panels should be placed in to maximize solar energy generation. The materials we use are a light source, light detector, projector, cable, and chip. And the applications we use are lux light meter and torchlight. We conducted the experiment in an enclosed room and varied theta while measuring the lux value. This is our experimental setup. There were torchlight overhead, supported by the cable, while having the light detector on a pivot to vary the angle.
As seen from the results, we can see an increasing trend when the value of theta increased from negative 90 degrees to 0 degrees, and a decreasing trend when the value of theta increased from 0 degrees to 90 degrees. As theta approaches 0, the light intensity increases. When theta, the angle of incidence, is 0 degrees, maximum natural light intensity is reached, and energy efficiency is the greatest. In our experiment, the first source of error identified was that the experiment was conducted on a school chair with an uneven surface. This could have affected the angle of the setup and caused the final experimental results to be inaccurate. Hence, our proposed improvement is to conduct the experiment on a flat surface. Secondly, the presence of light coming in from surrounding windows might have been detected by the app, causing the recorded light intensity to be higher in magnitude than the actual value. Hence, our proposed improvement is to conduct the experiment at night and in a fully enclosed room to reduce the presence of external light sources, which could affect the recorded light intensity, hence obtaining the most accurate result. Lastly, the protractor is held freehand when measuring the angle theta. This could incur an increased absolute and percentage uncertainty, which affects the precision of the results. Hence, our proposed improvement is to use a retort stand to clamp the protractor tightly to ensure the position and angle of the protractor is constant throughout the experiment.
In conclusion, when solar panel is placed perpendicularly to the sun, the angle of incidence is lower. Higher angle of sun ray is able to strike the solar panel vertically at a shorter path length, more concentrated in a smaller area, resulting in more effective the heating, producing more solar energy. Vice versa, when solar panel is placed at an angle which has a angle of incidence which is higher, the sun's ray strikes the panel obliquely, making energy needed to spread out over a larger portion of the surface, hence less effective the heating, producing less solar energy. Therefore, solar panel is mostly effective at places where angle of incidence is lower, so more heating and leading to more solar energy produced. Such places like Singapore, which is usually located in the equatorial region. Next but not least, how does this help with our energy resilience? Such experiments help scientists to find out which angle the solar panel should be placed at to maximize energy efficiency. When we install the solar panels at the certain angle, we are ensuring that we are optimizing solar energy to generate more. Singapore will spend less money on energy because this energy efficiency is maximized.